So for question 12 is asking about the variation, saying that it's partly a constant and partly varies as x squared. So remember that when you see partly, you can write the fx is equal to k1 something plus k2 something. Okay, so that's the format. So now we have the first part is a constant, so just a k1. The second part is varies as x squared, so it's going to be k2 times x squared. Then we have this f2 equal to -1, which means that we can replace all of the x by this 2, and the whole thing should be equal to -1. So now we can say f2 is equal to k1 plus k2 times 2 squared. I replace the x by 2. This should be equal to -1. And the second one is f7, so that I change the numbers of x become to 7. So I have k1 plus k2 times 7 squared equal to -136. Then we simplify it, we have k1 plus 4k2 equal to -1, k1 plus 49k2 equal to -136. So this is actually simultaneous equations, two unknowns. I can just use program 01, 1 for -1, 149, -136. Get your answer, which is k1. K1 should be equal to should be 11, and k2, which is equal to -3. So now we can substitute back. So we can say our fx is equal to k1, which is 11, plus k2, which is -3 x squared. So I just replace this k1 and k2 by these two numbers to get our answer fx. But now they're asking about f5. So we can substitute 5. So I replace the x by 5. So 11 minus 3 times 5 squared, giving you answer should be -64. So now we've done part A, and now part B, part B2. Part B is going to be, we have 2 points. That's 5p, -5q. It's actually lying on the graph, this fx. So you need to find the area of PQR, but R is actually a point lying on the x-axis. So when you just read the wording question, it's very hard to you to do that directly. It's very better for you to draw the graph out. So let's try to draw this graph. So I draw it on the right hand side. So let's look at this fx. This is actually a quadratic equation, isn't it? So we can say the fx is actually equal to -3x squared plus 11. So which means that it's actually the a is smaller than 0, which means it's open downward, it's a set phase. And 11 means your y-intercept. So that we can say our graph should be look like this. Okay? So this is going to be 11, and this is set phase. It's open downward. So this is your 11. And now we have the x value is 5 and -5. So 5 is actually here, and -5 should be here. So I can draw a straight line. Here. So that's going to be p, which should be equal to q, because for quadratic equation it's actually symmetry along this y-axis. So now we can try to find out what is the value here. So for now, we can get the y value. You just substitute 5 in, so it's equal to -46, -64, which means that our line shouldn't be on top of it. Instead, we should draw it again, so that we can draw it this way. Because the y value is -64, so it should be here. Okay, so this is our -64. And then the intersection point here is going to be P and Q respectively. This is the x-axis, this is the y-axis, and this point is 11. And now we need to find out the area of PQR, but R is a point lying on x-axis. So it's a point lying on x-axis, but where is it? Can be here, can be here, can be here, but I don't know where is it. But we can actually just take a random point, say here, and we can link them together. Because where is this R, the height is going to be the same, isn't it? So let's try to move it. Where is this R, let's say here, and then the height is still going to be this. So the height doesn't change. So it doesn't matter where is our R is. Okay, so to find this triangle PQR, it's actually just using the triangle's formula you learned in primary school, the base times height. This is your base, and this is your height. So the area should be equal to the base times height divided by 2. But think about what is the length of this PQ. For P, it's going to be -5. For Q, it's going to be 5. So the distance between them is going to be 10. So you can say this is 10 times the height. The height is actually just the y values, isn't it? It's 64. It's -64, but the length of it is going to be positive values, so you just take the 64. So times 64 divided by 2, giving you the answer should be 320.